Okay, this is going to give you a description of project number 2 for computer and network security. This is going to be a fun assignment in my opinion. There's a little bit of configuration that we have to do in part 1. We get to write a program in part 2, and then we get to try to attack what we've done in part 3. So we're going to start off in part 1 by installing a web server, an application server, and a database. I'm hoping that you all have 2 different computers that you can work with. If it's a laptop and a desktop, 2 laptops, something like that. I'd like for you to try to run these 2 programs on different computers if possible, especially when you are attacking them in part 3. If you're not able to do this, hopefully you can run one of these programs on one of the computers in a computer lab on campus so that you are able to do this. Part 1, install a web server, application server, and database. One popular web server, application server is Apache's HTTP server coupled with Apache's Tomcat application server, which is a Java application server. If you want to go the Microsoft route instead, there's Microsoft IIS. There's also the Microsoft Personal Web Server that are on Windows machines, or that you can get on Windows machines. And then that already has an ASP application server built into it, so you don't have any other installation to do there. Those are both very popular web servers, so it's going to be good that you get experience with at least one of them during this assignment. You also need to install a database. A popular database is MySQL. It runs on Windows. It also runs on Linux and Mac. So you can download MySQL. It's free. It's very commonly used even in industry. If you want to stay with the Microsoft route, you can download a trial copy of SQL Server. If you don't have one, the lab computers may actually have a licensed version of SQL Server if you want to use that there instead. For those of you that want to try to install all of this on your in a bundle, there is some technologies called LAMP. LAMP is L-A-M-P, and that stands for Linux, Apache, MySQL, and PHP. So you can do that instead of using Java. There's also WAMP, W-A-M-P, which is Windows, Apache, MySQL, and PHP. So you can look at those also. Nice little bundles that have all of them already built into it, and you can have it installed very quickly on your own computer. Okay, part 2 is going to be a monitoring program. What we want to do is we want to monitor the web server, the application server, and the database to make sure that they are still up. I've given a little description there of what you can do for that. So you need to write a program that can communicate over HTTP. If you don't know HTTP, look it up. There's just a header that you have to create with 2 new lines at the end of it, and then you have the actual data, which is going to be transmitted. Not very difficult to do. You may have actually done this already in the networking class if you have taken that in the past. So you need to just be able to send an HTTP request and see if the web server sends a response back to you, whatever the response may be. Just if it sends a response back to you, that is going to tell you that the web server is still up. To monitor the application server, we just need to hit a page that is handled by the application server. So if you have a PHP application server, hit a PHP page, and if a response comes back, that tells you that the application server is up. To monitor the database remotely, this one's going to be a little bit trickier to do. We can either provide an interface over a specific port to the database. So MySQL typically runs on a port, I think it's 3302. So you can try to see if you can create an application that just listens on that port, or that you communicate on that to see if the MySQL database is open. You have to be careful if you open a port through a firewall, though, that you aren't creating some kind of a security risk. So you need to be careful doing that. What you also could do is have a page that you hit through your application server that's going to run a query on the database and see if a response comes back. If you choose that, though, you have to figure out how you're going to make sure that to monitor the database if the application server is not currently up. It might not be that big of an issue if you can't hit the application server and that's the only way you're hitting the database. Then maybe you don't need to worry about monitoring the database if the application server is also down. Make sure that you document that and specify how you're doing it. One other note that I put in that section is make sure that you are not hitting your web server, application server, and database too frequently, because you don't want to create your own denial of service attack just with your monitoring programs. Okay, part 3, and this is where it's going to become a little bit more fun, is you are going to create some attacks. You're going to create 2 different attacks. The first one is going to be a denial of service attack. This is really easy to do. You just want to try to utilize as many resources on the server as you can. So if you write a program that just requests web pages constantly, then you will be eventually you will deny service because your web server won't be able to respond that frequently, or your application server, database server won't be able to respond. So that's one attack that I want you to use. Second, you get to choose your own attack. You can either create one on your own, or you can use one of the other ones that we have discussed, or one that you can find online for having a second attack on your web server, your application server, or your database. And what I want you to do, the fun part here, is that you've written your monitoring programs, and I want to see how quickly your monitoring program detects that an attack is taking place, that you have denied service, and how quickly your monitoring program will alert you that you have this attack going on. I think it's kind of a fun part. You see the grading criteria down there at the bottom. So you're going to write a document for me, and you're going to submit it to me. Make sure that you have screenshots and you document everything that you've done. This is the only way that I'm going to be able to verify that you have completed this assignment. So 2% for the clarity of the document, 2% for making sure that it's grammatically correct. Please go back over your document again and make sure that you don't have any spelling mistakes or grammar mistakes in it. And then 3% for documenting part 1, 3% for documenting part 2, and 5% for documenting part 3. Obviously, I understand that it's not just the documentation that I'm grading here, but I'm also grading that you have done each one of those parts. So that's what I'm looking for in the documentation, is proof that you actually have completed each one of the parts. Okay, if you have any questions, let me know. Good luck.